Hello everyone. In this video, we will learn all about limits of a function. Limits of a function tells us the value that a function approaches as that function's inputs get closer and closer to some number, just like this one. As this graph approaches 0, its value is -4. While as the other graph approaches 0 from the left, it is approaching 1. Limits are considered as the building blocks of calculus, in which calculus is called the mathematics of change. The study of limits is the basis of all calculus. It is necessary in studying change in great detail. The evaluation of a particular limit is what underlies the formulation of the derivative and the integral of a function. This is the notation of a limit. This is read as the limit of f of x as x approaches c is L. In this case, this f of x is considered as the function. This x as you approach c along the x-axis. Well, L, what is the y value getting closer to? For starters, imagine that you're going to watch a basketball game. When you choose seats, you would want to be as close to the action and to the players as possible and have the best view of the game, as if you were in the basketball court yourself. Take note that you cannot actually be in the court and join the players, but you will be close enough to describe clearly what is happening in the game. This is how it is with limits of functions. We will consider functions of a single variable and study the behavior of the function as its variable approaches a particular value. The variable can only take values very, very close to the constant, but it cannot equal the constant itself. However, the limits will be able to describe clearly what is happening to the function near the constant. Given this, what is the limit of 1 plus 3x as x approaches 2? In this case, we will simply substitute 2 to x. So this will be 1 plus 3 times 2, or simplifying further, we will have 7. Now, making use of table of values, we will have this one. If the x is 2, y is 7. If x is 3, y is 10. Now, take note of this one. From the right, as x approaches 2, the value of y is also approaching 7. So the same thing from the left side. So if our x is 1 here, substitute, we'll get 4. Now, as the value of x approaches 2 from the left, the value of y is also approaching 7. Now, sketching this in the Cartesian plane, we will get this one. So the same thing. As our x is approaching 2 from the left, it is approaching 7. So, approaching 2 from the right, the value for y is also 7. So, that is the concept of limits. So, you have to look at it from both left and right. So, another. So, given this, y is equal to x squared plus 1. What is the limit as x approaches -1? So at this point, this is our graph. As it approaches -1 from the right, it is approaching 2. As x approaches -1 from the left, the value is also 2. Okay, another example. So given this is the graph of the absolute of x. What is the limit as our x approaches 0? Now from the right, as our x approaches 0, the value of y is also 0. So from the left, as our x approaches 0, the value for y is also 0. So 0 is the answer here. Now, for this one, evaluate the limits of the following. So again, for easy limits, all we have to do is substitute right away. So with this one, 3 squared plus 1, so this is 10. Another, 5 over x plus 2, as our x approaches 2. So again, with this, substitute. So simplify. This is 5 over 4. Another. What is the limit of sine x as our x approaches 0? So with this one, sine x, so that would be sine of 0. Sine 0 is 0. So take note, this is easy limits. So all you have to do is substitute right away. Now it will be different if the given function will have the indeterminate form 0 over 0, or if the denominator is 0. Because in math, any number divided by 0 is always undefined. So for example, if I'll give this, what is the limit of x squared minus 4x plus 3 divided by x minus 3 as our x approaches 3? Now take note in this one. This 3 here, if we will substitute in the denominator, it will give us 0. Now take note, never divide by 0. So for cases like this, there are two things that you can do. It's either you factor or you rationalize first. Now in this case, we will factor. So factoring the numerator, we will have x minus 3, quantity x minus 1 over x minus 3. So at this point, we can cancel x minus 3 and x minus 3. That will leave us with the limit of x minus 1 as our x approaches 3. Now at this point, we can now substitute. So this will be 3 minus 1, or simply it is 2. Now, making use of the table of values, we will have this. Now take note, if our x is 3, it will give us an undefined value, or it does not exist. If it's 5, it will give us 4. If it's 4, it will give us 3, and so on. So take note, as our x approaches 3, the value for y is also approaching undefined, or 2. The same thing from the left. If your x is 1, our y is 0. So as our x approaches 3, the value for y is also approaching undefined value, or that would be 2. So graphing this one, we will have this. So take note, as we approach x as 3 from the left, it will give us 2, and from the right, it will also give us 2. But it is actually open. It's because of this. Okay, next. Okay, another example. This one. What is the limit of x squared minus 9 divided by x minus 3 as our x approaches 3? So at this point, again, when we substitute x with 3, it will become undefined. So with that, we will factor this one. So x minus 3 times x plus 3 over x minus 3. So you cancel x minus 3, that will leave us with x plus 3. Substitute x with 3, so therefore we'll have 6. Okay, another example. This one. What is the limit of x squared minus x minus 2 over x minus 2 as our x approaches 2? So at this point, let's factor this one. So that would be x minus 2 times x plus 1 over x minus 2. So we cancel this. We are left with x plus 1. So substitute. So that would be 2 plus 1, or simply it is 3. So take note of this. Okay, this one. What is the limit of x cubed minus 6x squared plus 10x minus 4 over x minus 2 as our x approaches 2? Now take note with this, our exponent here is 3. So to easily factor this one, we will make use of synthetic division. So to do synthetic division, the first thing we do is identify the coefficients of our dividend. So with that, we will have 1, negative 6, positive 10, and negative 4. While our tentative divisor would be positive 2. So with this, the first thing we do is bring down the first coefficient, which is 1. So 1 times 2, we'll get 2. Then add, this will be negative 4. Negative 4 times 2, that would be negative 8. Then add, we will have positive 2. 2 times 2 will get 4. And add, we will get 0. Now take note, this one, when we divide, we will subtract the exponent. So if this is 3 and this is 1, so with this, our quotient would become x squared minus 4x, then plus 2. So with this, rewriting this one, we will have the limit of x minus 2 times x squared minus 4x plus 2 over x minus 2 as our x approaches 2. At this point, we can cancel x minus 2 and x minus 2. So with that, we will have this one and substitute this with 2. So we will get this, and simplifying further, our final answer is negative 2. Okay, another. What is the limit of x minus 4 over the square root of x minus 2 as our x approaches 4? Now at this point, we have here a radical. So to do this, we will rationalize this. And rationalizing this one means multiplying it with its conjugate. So the conjugate here, which is square root of x minus 2, is square root of x plus 2. So take note, this one is just the same as 1. So at this point, so multiply the numerator and the denominator, so we'll get this. So multiply this, and since our denominator here, we have here sum and difference of the same roots, so its product will be the difference of its square. So square root of x times square root of x will get x. Negative 2 times 2, we will get negative 4. At this point, we can cancel x minus 4, so we're left with the limit of square root of x plus 2 as our x approaches 4. At this point, we can substitute 4 right away, so simplifying, we will end up with 4. Okay, another. Now take note, what is the limit of x squared minus 1 over the square root of x minus 1 as our x approaches 1. So take note, our conjugates here would be the square root of x plus 1. So simplifying this one, multiply this, so we can rewrite x minus 1 as x plus 1 and x minus 1. So this one, square root of x and square root of x will get x. Negative 1 times 1 will get negative 1. At this point, we can cancel this, so we're left with the limit of x plus 1 quantity square root of x plus 1 as our x approaches 1. So substituting this one and simplifying, we will end up with 4. Okay, another. What is the limit of the square root of x minus 3 over x minus 9 as our x approaches 9? So at this point, we will have its conjugates, which is the square root of x plus 3. So simplifying this one, square root of x times square root of x, that would be x. Negative 3 times 3, that would be negative 9. And multiply the denominator. So at this point, we can cancel x minus 9. So we're left with the limit of 1 over the square root of x plus 3 as our x approaches 9. So substituting this one, we will end up with 1 over 6. Okay, another. This one, the limit of the square root of x plus 2 minus 3 over x minus 7 as our x approaches 7. So again, multiply this with its conjugates. We will have square root of x plus 2 plus 3. So simplifying this one, so x plus 2 times x plus 2 would be x plus 2. Then negative 3 times 3, that would be negative 9. So take note, 2 minus 9, that would be negative 7. So at this point, we can cancel this, and we're left with the limit of 1 over the square root of x plus 2 plus 3 as our x approaches 7. So substituting this one, we will end up with 1 over 6. One-sided limit. What is the limit of the square root of x as our x approaches 0 from the left? Number 2, what is the limit of the square root of x as our x approaches 0 from the right? So take note, if our exponent here is negative, it indicates from the left. And if this one is plus, it indicates from the right. So making use of table of values, we will have this one. So 0, so square root of 0 is 0. If we will substitute it with the numbers to the right of 0, so square root of 1, we will get this 1, square root of 2, square root of 3, and square root of 4, which is 2. Now, with the numbers to the left of 0, Like the square root of negative 1, take note, it is imaginary. So square root of negative 2, square root of 2i, and so on. So graphing this will be this one. So it starts from 0 until infinity. So take note, to the left of 0, it is already imaginary. So with this, looking at the graph, what is the limit of the square root of x as our x approaches 0 from the left? Our answer would be D and E, or meaning it does not exist. While the limit of the square root of x as our x approaches 0 from the right would be 0. So take note, when you say one-sided limit, there are two possible answers. It could be it does not exist or it is 0. Okay, another example. This one, the limit of the square root of x minus 2 as our x approaches 2 from the left and from the right. Now making use of the table of values, so if it's 2, so 2 minus 2, that would be 0. If we will make use of 3, so 3 minus 2 will get 1. And 4, we will get square root of 2, and so on. While numbers to the left of 0, like 1, so 1 minus 2, that would become negative 1, which is imaginary. So with this, our limit of square root of x minus 2 as our x approaches 2 from the left would be it does not exist. While as it approaches 2 from the right, our answer is 0. Next, the limit of the square root of 3 minus x as our x approaches 3 from the left and from the right. Now making use of the table of values, so 3 minus 3, that would be 0. Now to the right of 3, like 4. So 3 minus 4, that would become negative 1, so therefore it's imaginary. While to the left of 3, like 3 minus 2, will end up with 1, so that would be 1, and so on. So with this, the limit of the square root of 3 minus x as our x approaches 3 from the left would be 0. While as we approach 3 from the right, that would be imaginary. So it does not exist. So take note of that. Okay, next. The limit of a function at c versus the value of the function at c. So take note of this. What is the difference? So when a limit does not exist. Okay, so if we're given here, the limit of a function as it approaches c from the left is 4, as it approaches c from the right is 4, and as the value of f of c is also 4, it means the limit exists. Now for this one, this is 5, 4, and 4. So with this, the limit does not exist. While this one, from the left is 5, from the right is 5, but f of c is 7. With this, the limit does not exist. So therefore, a limit does not exist if from the left, it is not equal from the right, and it is not equal with f of c. So with this, a limit exists if and only if all of these values are equal. So let's have an example. Okay, what is f of x as x squared minus 5x plus 4 over x minus 1? So with this, graphing this, we will get this. Now this is the graph of this function. So question, what is the limit of the given function as it approach 1? So take note, this is 1 here, 1 from the left. So looking at this, 1 from the left, our value here is it is approaching negative 3. Now, as it approach 1 from the right, the value is also approaching negative 3. But if our x is exactly 1, what is our y? Our answer here is it does not exist. Okay, why? It's because looking at the graph, it is open at x equals 1. So take note of that. Now making use of the table of values, we will have this. So as our x approaches 1 from the right, so the value is also approaching negative 3 in y. As our x approaches 1 from the left, the values in y is also approaching negative 3. But if our x is exactly 1, it is undefined or it does not exist. That's why it is an open circle. So the same thing here. So since we cannot substitute 1 right away, so we need to simplify. So with this, our answer would be negative 3. So take note of this. Okay, another. Now, given this is an example of a piecewise function. So it is a function composed of multiple functions. So, function x plus 1 if our x is lesser than 4. And x minus 4 squared plus 3 if the value for our x is greater than or equal to 4. Now, with this, the graph of this is this one. So let's identify the limit of f of x as our x approaches 4. So this one, as it approaches 4 from the left, our value here is positive 5. While as our graph approaches x from the right, it is at 3. Now, if our x is exactly 4, our value is also 3 because it is shaded at this point. So, take note of that. Okay, another. This one. So, f of x is negative 2 if our x is less than 0, and it is 3x if our x is greater than or equal to 0 as our x approaches 0. Okay, now with this, we will have two table of values. The first one here is if our x is lesser than 0. So lesser than 0, so that would be negative 1, negative 2, until negative infinity. So take note, the value for our y here would be negative 2. Now another table of values will be for the second function, in which if our x is greater than or equal to 0. So the least value here would be 0. So 0, so 3 times 0 will have 0. If it's 1, so that would be 3. So 3 times 2 will get 6, and 3 times 3 we will get 9. So this will be for the second function. Now graphing this, we will get this one. For the first graph, if our x is less than 0, our y is negative 2, but it is open here. Now, if our x is greater than 0, so we will have 3x. So that would be 0, 0. We will have 1, 3. We will get 2, 6, and so on. So therefore, this will be our graph. Now, looking at the graph and the table of values, what is the limit as our x approaches 0 from the left? Now, this is 0 from the left. It is approaching negative 2. But it's different when you say the limit of the function as x approaches 0 from the right, because it ends at 0. Now, if our x is exactly 0, the answer here would be 0. So take note of that. Now, given this function, if our x is less than 0, that would be x minus 2. If our x is greater than or equal to 0, that would be x squared plus 1. So find the limit as our x approaches 0 from the right and from the left. Now take note, making use of the table of values for the first function, that would be numbers that are lesser than 0. So if it's 0, so 0 minus 2, that would be negative 2. If it's negative 1, so negative 1 minus 2, that's negative 3, and so on. Now for the second function, this would be numbers that are greater than or equal to 0. So 0, so 0 squared plus 1, that would be 1. If it's 1, so that would be 2, and so on. So graphing this, so this will be our graph. If our x is lesser than 0, so this will be our graph. So this will be for this TOV. Now, if our x is greater than or equal to 0, we will make use of this. So it is quadratic. So with this, we can now identify. if our x is exactly 0, the value for our y is 1. So it's shaded here. What is the limit as our x approaches 0 from the right? So from the right until 0, the value for y is 1. Now, as our x approaches 0 from the left, the value for our y is negative 2. So take note of that. Now, given this graph, this is a graph of function. So let's identify its limit as x approaches c from the right, from the left, if our f of c, what's the value, and make the conclusion. So for number 1, let's start with negative 2. If our x is negative 2, so this one, as it approached negative 2 from the right, so from the right, our value here would be positive 1. Now, approaching negative 2 from the left, the value for our y will end at positive 1. Now, if our x is exactly negative 2, the value for our y would be positive 1. So take note, all of this, it's equal, so therefore the limit exists. Okay, next, if it's 0, so 0, this one. So approaching 0 from the right, the value for our y is 3. Now approaching 0 from the left, the value for our y is also 3. But if our x is exactly 0, the value for our y is, it does not exist. Why? Because it is unshaded at this part. So therefore, our conclusion here, the limit does not exist. Okay, next, what about for 3? If our x is 3, so here, as x approaches 3 from the right, the value for y is positive 4. Now, as our x approaches 3 from the left, the value for y here is, it's approaching 0. But if our x is exactly 3, the value for y is positive 2 because it is shaded at this point. So, in number 3, the limit still does not exist because all of this have different values. So, take note of that. Okay, the limit laws. So, these are the different theorems and their corresponding example. The limit of a constant, so is always the constant itself. So the limit of 4 as x approaches 2 is 4. Next, identity limit. So the limit of x as x approaches 8 is also 8. Next, the limit of a constant and a function. So the limit of 4x as x approaches 2. So basically it's 4 times 2 or it is 8. Next, the limit of sum. So the limit of x plus 7 as x approaches 2. So that's 2 plus 7 or therefore it is 9. A limit of difference. So x minus 7 as x approaches 2. So 2 minus 7, it is negative 5. Okay, next. The limit of product. The limit of 3 quantity 2x plus 1 as x approaches 2. So all we have to do is substitute. So 2 times 2 is 4 plus 1 is 5 multiplied by 3. So therefore it is 15. Next, the limit of quotient. So with this, it's division. So 2x plus 5 over x plus 3 as x approaches 2. So substitute, that would be 9 over 5. Next, the limit of power. So like 3x plus 4 to the power of 3 as x approaches 1. So again, substitute x with 1 and 3 times 1 is 3 plus 4 is 7. 7 cubed is 343. And the limit of radicals. So the limit of the cube root of x squared plus 4 as x approaches 2. So at this point, substitute x by 2. So 2 squared is 4 plus 4 is 8. Take note, the cube root of 8 is 2. So take note, all of this summarizes the different limits that we had. Okay, so take note. So that would be all about